Yeah, so my name is Andrey, so for those who don't know me yet. I'm a Java Groovy developer. I have also written a book on Groovy 2, Groovy 2 Cookbook. But in the last few years, I've been exposed so much into operations. So some people may actually call me a DevOps guy because I'm doing a lot of automation, software delivery, automation and operations part. But still remaining a Java developer and a Groovy developer in essence. And by being exposed to operations tasks, to system administration tasks, and to automation tasks, I have been using scripting languages, including Groovy, of course, to implement this kind of things, like maintenance scripts for backing up, for cleaning up, for monitoring, cron jobs, scheduled stuff, different automation tasks for deployment, for releasing, for packaging, for testing, for all that stuff. Also, I've been using simple web applications to expose some status checks, monitoring, backdoors, for helping out with deployments and all this stuff. So all these areas definitely require scripting. And of course, there are many scripting languages available. So you would ask why Groovy? And I would say that it's a logical choice for Java developers. If you don't know Groovy yet, then well, learning Groovy, if you're a Java developer, is almost zero effort because 100% of, almost 100% of Java code is directly compilable by Groovy. But at the same time, Groovy offers a lot of goodies on top of that, which makes scripting, especially scripting, very pleasant experience. Of course, there are a lot of native scripting languages available, as I mentioned, and for Linux environments, we have gazillion dash, bash, zash, and what kind of different shell languages, and well, all of them have different features and different quirks that you have to know when you code against them. And of course, there's definitely a place for them. I'm not saying that we should replace them with Groovy, but if you are working in a Java project and if you're a Java developer, then Groovy may help you out to create more concise and more readable scripts than you can actually create in Bash and other. And if we're talking about Windows environments, of course, there's bat files and CMD files and eventually PowerShell files, which call themselves Posh. And recently, like a month ago, PowerShell was released on Linux environments, so you can actually use PowerShell in Linux now. And you could use Bash on Windows environments for a long time already. There are some announcements of that, maybe Microsoft, that they created a new version, but actually it was possible to use Bash on Windows for a long time. So yeah, the scripting, native scripting is kind of segregating, uniting, but still for automating everything around Java project delivery, I would still prefer using Groovy. Especially the main reason for that is that the more complex the code gets, the more real data structures, real programming language facilities you actually need. I found this kind of blog post somewhere where people are trying to implement arrays in a bat file. Well, it is possible, but probably it's not something you want to do. And especially the poor guy who will actually read the code after you implement this kind of stuff. I don't think it's a maintainable code base that you end up with. And yeah, there are two books on Bash and PowerShell. And well, they're valid books, but they tell very nice things. One thing that I noticed, and probably see guys do that as well, this turtle seems a bit more happier than the PowerShell turtle. On the other hand, it's still shell scripting, so it's a bit limited to what it gives. Also, this book, if especially the latest edition, if you take it, it's gonna like almost 1,000 pages. This one is a bit shorter, so obviously the learning curve is still better with Bash. PowerShell is okay, but it's probably getting too complicated, and it started from the wrong end, in my opinion. So in that sense, I would prefer using something that I already know, and especially for automating tasks around Java applications. And Groovy is a logical choice here. First of all, because it runs on Java, and we all know that Java is multi-platform. We can run it on any operating system. And whenever we can run Java, we can run Groovy. And it works on Windows, obviously, because Java works on Windows perfectly. But it usually could be a problem with the native system scripts, especially with Bash scripts. They may work on Linux environments, but for Windows you may have to create specific scripts that work specifically on Windows. For that purpose, Groovy again could be serving as a multi-platform independent language that can script. You can use the same code to script automation task on any operating system, which is very handy. And because it's a programming language, real programming language, which started as a programming language, and it has a lot of syntax Sshoogr and libraries, and it has closures for functional paradigms, it actually ends up you can create very maintainable code with that, much more readable than you can get with native scripting tools like Bash or PowerShell. Also, Groovy is quite old. It's more than 10 years old. It's quite stable ecosystem. Plus, of course, you can use everything you can use in Java, all the libraries that you have in Java. You can reuse your experience with using different libraries, Java libraries in Groovy, because they're directly accessible. And you don't have to forget that Groovy is nothing else as just a jar. It's a jar. It's a tool that you can just run as a jar from your command line, and there's nothing else. It's just a library. So there's no additional installation, no specific installation that is needed. There is no that big overhead if you already have Java on your systems. And yeah, my main point here is that you can reuse your JVM knowledge and your Java library knowledge to actually write Groovy scripts. Another thing that, actually quite a nice thing that Groovy ecosystem offers, different tools like RVM and RubyEnv from Ruby environments, from Ruby ecosystem. But now it's a tool for installing Groovy, Gradle, different Java SDKs. That's why it's called SDK. So you can also install Grails and different stuff, different tooling, and you can do it from a simple command line. So basically it's a Bash script, and if you run Linux environments, you can install it directly like that, getting the script from HTTP, and this will install the SDK on your machines. And personally, I usually install it everywhere where I need to maintain Groovy scripts, run Groovy scripts, and then SDK. You get the SDK command, which allows you to install different runtimes, different SDKs in your environments, and switch between them conveniently. So if you need different versions of Groovy, different versions of Gradle, Grails, whatnot, you can do it quite conveniently from the command line. I'll just make a quick demo of that. So yeah, I have this SDK. Do you see it? I can run a command called SDK list Groovy. It will list all the Groovy runtimes that are available in this machine. And at this point, you see quite many I can install. And the one that is installed currently is 2.4.6. If I want to install a new one, I can always, I think it was like that. And it will download and install Groovy 2.4.7 for me, the latest one. So it's a very handy tool, especially if you need to quickly start scripting something, and it's usually worth installing on machines that you're going to use Groovy for. There's also an alternative in Posh, but in PowerShell, but it's a bit outdated, and for me, actually, it doesn't really work. Even though I use Windows as my primary laptop, I still prefer using original Bash from SDK man, and then it works fine. One thing that some people may complain about Java in general, that the runtime starts, the startup time for runtime could be noticeable. And Groovy has an answer for that. It's called Groovy Serve. Basically, it's a small client-server application which runs the Groovy runtime in the background and allows to start Groovy scripts faster. So, for example, in this case, if you run Groovy script with printing hello Groovy, then it will take roughly 2 seconds on this system. But if we run it through a Groovy client, which starts a server behind the scenes and keeps the JVM for scripting running all the time, the time is much faster. So if you're really concerned about JVM startup, and you really need fast response from your Groovy scripts, you can use Groovy Surf for that. And Groovy Surf can also be installed through SDK man. Okay, now let me show you some Groovy syntax that allows writing very nice scripts with the help of Groovy syntax Sshoogr. And of course, the most things that I do usually with the different automation scripts, I'm manipulating files and directories. And in Groovy, the file object is the same as Java file object. It's just that it adds on top of that different utility methods that can be used for much more concise code. So in this case, we just get the file in the same way you would get file in Java. But the good thing is that you don't need to import that file, so it's just use it. And then when you get the file object, you can just get the full text of that object, and you can get byte contents of that object and manipulate that in the same way you would do in Java. Also, Groovy supports the left shift operator, which allows to direct content into the file. So this one looks very much like you would do in a command line on Bash or PowerShell, redirecting contents to some file. You can do something similar in using the plain Groovy syntax. Also, if you work with the remote data like URLs, some of the methods that are available in file, they're also available on URL objects, and again, this is a Groovy add-on on top of normal JavaNet URL class, which allows us to get the text of the whole URL data and assign it to a file, for example. So it's a simple download utility that you can implement in Groovy with just one line. You can also do multi-lines. That's sometimes pretty handy. There's also the left shift operator, which I showed already. Also, all the abstractions that Java has, like writers, input streams, and all that stuff, are also available, but has additional stuff, additional goodies. So in here, for example, we can open the file with the writer, and it will give us the writer object. And the good thing is that we don't need to think about closing that writer, because it will be closed as soon as we leave this code block. So again, writing something like that in Java is possible, obviously, but it will take probably three more lines, three more times lines of code than in Groovy. So working with files with different input streams and output streams is very easy, especially using this left shift operators, this closure, which auto-close the resources for us. And yeah, it's very pleasant in general. We can also navigate the lines if you want. Sorry. And this closure construct allows us to iterate over lines if we want to. We can do that also using each line method or each byte method if we have such a need. Also, something that I often do as well is filtering files based on some condition. So this is one of the possible implementations that we can do. So we open one file with writer, and we open another file and just reading each line, and then filtering that and outputting that to the writer. Something that can be implemented also with the shell script commands, but in Groovy it's also possible to do like that. That's actually the same thing, but in more concise form. We can also do transformations like that if we have a reader. And it's really worth exploring what Groovy adds on top of a normal Java object, because it will give you a lot of nice things like this transform line, filter line, and all these kind of methods. And you can always also do things like that, just replacing the full contents of the file. But of course, you have to know that the file is not super big, because otherwise you can run out of memory. Another nice feature of file object additions that Groovy adds to the file object in Java, file class in Java, is that you can actually navigate the directories, traverse the directories with some handler methods like each file and each directory. You can also do it recursively, using each file recurse, each recurse. Also, there's a very powerful method called traverse, which takes a lot of different parameters, which can allow you to filter execute different code based on the filtering and naming match and all that stuff. Very powerful, and at the same time quite concise, and in my opinion stays quite readable as well. So for example, like this, we can traverse the name filter and do something with the file that we found. That's more advanced example. So we searching for the files, we using the name filter, we're also excluding some of the names, and then we do something inside the code block. So it's kind of very functional way of doing things, like passing disclosures with code against some input operators. At the same time, it's, in my opinion, it's quite readable as well. Another good feature of Groovy is that you can extend existing classes with additional methods. So, and then this leads to a situation where you can create very nice DSLs, very expressive DSLs on top of existing objects. So in this case, well, each normal class in Java, in Groovy, each class will have a meta class definition to which you can add a new method, let's say save delete, and you can assign a closure. This is a closure block, code block, which implements that method. So, and then basically, inside this closure, inside this code block, you have access to all the methods of the file object, and basically exists is directory, delete there are the methods available on the file object that is passed to this closure as a delegate and will be called eventually. And when we define this kind of save delete method somewhere in our code block, in our script, we can after that just call it in the same way as it was method on the file object, on the file class. So it's very handy, especially if you can put this code aside somewhere in the additional scripts. Then you can make your main scripts look very readable because you hide all the logic behind the scenes. And the way you can do that is that Groovy accepts, Groovy command can accept a base script object. So when you run Groovy script, you can also provide additional script which will be executed before your main script, where you can put all your utility libraries and your utility methods, and then make the main script quite concise and readable. So in this case, we should create a base script which extends the script, and we can extend the meta class for file to add the save delete, and in order to run it. Of course, we will use that method inside our main script, which can be delete.groovy. But in order to combine this all together, we have to run this with this command, so -b base script delete.groovy, and all the methods will be available inside delete.groovy. So you can create very concise and reusable utilities then that you can reuse among different scripts. Groovy also has facilities to run external commands inside the Groovy script. And this is actually an extension on top of the string class. So in this case, what we do, we run a ls command, which is a string. And a string has a method called execute. And that's of course, that's a Groovy extension that we don't have that method in Java. And the execute method returns a process object, which we can operate on. So in this case, we just get the exit value from the ls, and we can then check it on. Also, because it's a process, it's a normal Java process object that you'll find in the Java API. Groovy also added some stuff on top of that, like input streams, and from input stream you can add each line and do something with that. You can also do forking, you can do timeouting and stuff like that. You can also combine together standard output, standard input, standard error. And another thing is that Groovy also defines this pipe2 operator, which this is the long form of doing this. But you can also use the pipe operator to actually combine two processes and stream output of one process to another process. So it looks very much like what you would do in command line. But in this case, it's fully Groovy code. Also, of course, your scripts most likely will have some arguments, and Groovy has a class called CLI Builder, which you can use directly and you can define what are your parameters and do some logic for parsing those. Another nice feature of Groovy is that it has a lot of operators that allow you to write more defensive code. And of course, you wouldn't like have a null pointer exception in your script, and like also in your code. So, for example, in Java, when you want to have this code, user get address get city, there's a chance that user is null or user get address is null, and you get an NPE. The same actually will have in Groovy if you write things like that. First of all, it's a more concise form that will actually transform to these calls. So you don't need to write get in Groovy, you can just write address. But still, this code suffers from also potential and null pointer exceptions, because some of the path in this expression may be null. So Groovy adds so-called safe navigation operator, where you just write question mark dot and then question mark dot, which will basically, if this is null, not null, then the rest of the expression will not be calculated. It will just return null immediately. The same true is here. So you will get null, but you will not get null pointer exception because some part of the expression is not cannot be calculated. So this safe navigation operator can help you out to create very defensive scripts, which at the same time look very concise. Because you can obviously implement this in Java, but this would definitely be much more code. There's also Elvis operator, which allows you to define a default value. So in this case, the expression will be transformed to no idea if any of these objects is null. And again, it's very concise. Groovy is well known for writing DSLs, domain-specific languages. And with all the facilities, with all the syntax Sshoogr, with closures, you can write very nice scripts with that. Imagine we have such a DSL, like a transaction, which executes requests. So we have many scripts like that, which do some logic behind the scenes. We don't know which. And to implement this kind of nested definition language, the domain-specific language, is quite easy actually. First of all, you need to define a transaction method, because this is a method call, and because of the Groovy syntax Sshoogr, we don't need to specify the brackets. We can just pass the code block, which is a closure, as the last parameter, and Groovy allows us to write it like that. So it looks like we actually introduce a new keyword in the language, but at the same time, it's just a method call to some existing class or script. So yeah, this is how the method definition looks like. So transaction, and we pass a code block to that method. And inside that code, inside that method, we get the delegate for our closure. And we assign it to some request processor. So everything that is inside the closure will be delegated to this class. So the request method will actually be called on the request processor object. But we don't say it here. We say it inside the transaction method using the closure object. And eventually, we call the closure by also assigning the delegate here. And closure, when it executes, it will execute request method for every one here. And request method is basically belonging to this request processor class, where we do some logic here inside. And in fact, we're just collecting the data here. So we're collecting the data structures for the request object. And then here, in the transaction method, when we executed the method, when we delegated the calls to the request processor, we get all the data, and the processor object is filled with all the requests. And after we get the data, we actually execute the code, execute the logic. So it's like 20 lines of code, and written in very simple DSL that can actually reside in the script quite easily. And request object is just a data object with some data fields. Make sense? Okay. How much time? So, and Groovy also is quite popular because of this DSL, because of the closures, because of the different dynamic programming facilities that Groovy provides. Groovy is also very handy for different data type manipulations, and we can actually use dynamic parsing, dynamic typing for let's say XML parsing. So we can get, you can use XML sloper to get a tree structure, a graph of XML resources, and you can navigate them using this kind of syntax. So we get a bibliography object, and then the auth element inside that object, we can refer it like that. So it looks like normal code, but it's like, because of dynamic typing, we can do that. And the same we can do with the other objects, and we can also apply, if we get a collection of plays from the bibliography, we can also apply some filters on top of that, we can apply some iterators on top of that, and do very concise and nice processing of that. And the thing is that, well, many other data types, or data sources, data formats, actually work in a similar way. So you can actually do the same with JSON sloper. You get the same structure, which is, you know, under the hood is basically a tree of map of lists, or list of maps. And you can navigate that in the same way. So you can get the root element, then get the sub-elements using just the name of the element, like items, axis, and then again apply different filters on top of that, different iterators, and also apply get the final fields on top of that. And both XML and play and JSON, they look very readable because you don't need to dig into details how to parse that. You go directly to the element and you get what you want. So it again ends up with very, very much readable scripts. Yes, another good thing about Groovy scripting is that Groovy provides grape annotations that can download dependencies inside your script. So you pretty much can download any library that is available in Maven Central repository and use it in your script, and all that information will be residing inside the same script. So it's very self-contained. It will be very self-contained script. You don't need to write build scripts or installations or anything. You just write the script, grab your stuff, import it, and use it. That's it. That's very handy and very good for self-contained scripts. And you can put that grep annotations on pretty much anything, like on variables, on methods, on classes, on you can also you can import multiple jars if you need that. And the magic that Groovy does behind the scenes, it downloads them and puts them directly on the class path when it starts the script, which is very handy. And also, it downloads them only for the first time, and obviously it caches them inside the user directory somewhere. So the second time you run the script will use the cache dependency, so it's not, it will not do that every time. So there are possibilities to actually override some resolution strategies, but again, that's not so important. So you can actually use different repositories. You can use your own organization repositories to get dependencies from. So if you don't want to depend on the internet, for example. Okay. Also, there are several libraries that can help automating different stuff, joining together, gluing together different components. For example, HTTP. There's HTTP builder, which again, you can grab it using the grep annotation. You can import the code, and then you can use the HTTP builder class as a way to build complex HTTP requests. So for example, you can do a post request on some URL, some query string, and you can define two closures, two code blocks, which you will execute in case of success and in case of failure. So very functional way of doing things, but at the same time very, very concise and also quite readable. The same goes with SQL. So if you have to combine SQL data with HTTP data, with XML, JSON data, it's really few lines of code in Groovy. And there is a class, GroovySQL.SQL, which provides these handy capabilities, and it's basically a JDBC implementation on top of that, behind the scenes that used. So you specify the URL, the driver, so everything you know from Java, you can do it also in Groovy. And it provides, this SQL object provides different handy methods for iterating over the rows, giving you the actual object, which is a row object, and you can also reference that, the fields inside the object by using a simple notation like that. So transforming from XML to from a database query to XML actually in Groovy would be very easy because of this kind of syntax. Another nice thing that not many people know about Groovy is that you can actually you can run Groovy script as a server. So in this particular case, what we start is that we start a script on the port 4444, and on each line that the server gets, we run some code. In this case, it's just a new date. I can show you how it works. So Groovy. So Groovy is listening, and now I can use basically a telnet to connect to that server on port 444. Hello, how are you doing? So yeah, you can see that Groovy replies. And of course, we can make more complex stuff. And this may be one of the ways I use that actually is to implement some simple status checking on the servers where was no other way of doing that. Okay. For those who haven't been in my Ratpack talk, there's another good tool in the arsenal of Groovy libraries. It's called Ratpack, and you can grab Ratpack in the same way as you grab some other libraries. And what is Ratpack is basically is a simple web app, web HTTP application tool that you can use for exposing status codes, dashboards, and stuff like that. And the way you do that is that you have to write this kind of code, which forms a handle chain for your web application. And of course, you can put more complex code here, so not just exposing the date, but actually exposing some information about the system in HTML, and JSON, XML, whatever it is. And this can run as a server. When you start this, it starts a HTTP server behind the scenes, and you can use that server in your other automations if you need that. Oh, yeah, I use it quite often as a backdoor if I have no other way to implement proper automation stuff. Another goodie that I can recommend using is called Sshoogr, and that's basically a SSH wrapper for Groovy, which allows to create concise remote connectivity scripts. And again, you can just grab it like that. Then you can set up default connectivity options like default user, default key file you use to connect to the SSH server, different execution options. And then you can just execute remote commands. So something like remove stuff or touching stuff, or actually also it provides some abstractions, some remote abstractions that allow you to work with remote files, for example, in the same way as it would be a local file. So in this particular case, we assign full contents of a file to some value. And of course, it will be remote file that will be changed, not local file. And will happen in the context of this remote session. You can also, of course, assign multi-line files. You can also copy stuff using SCP. So in this case, there's a simple DSL here that, well, it's kind of readable, I guess. You're copying from local directory into remote directory, and you can exchange them if you want. You can have more than one directory if you want that. And yeah, this is a simple SSH stuff to implement with Groovy. And of course, on top of that, you can also implement some different checks and verifications, for example, because the exec command, exec method returns you a full rich object with which contains the remote command exit status and remote command output, and you can do some parsing in your script, but at the same time will happen. The command will execute remotely, but the decision about what to do with that result will happen inside your local script. Could be very handy. Also, there are some shortcuts, like if this command was executed okay, if it returns status that is not that is 0, then we can do code like this, or the same with fail. So it's again very nice to implement logic. Another thing that Sshoogr has, and which actually I use quite often, is tunneling, because there's often happens that some of the servers are located behind the jump server, behind the firewall, and the only way to connect to them is tunneling through certain port over SSH. So what happens here is that we connect over SSH to this IP address, and we open a port, and we create a tunnel on port 8080, and we start a local server with some random local port. And basically now we can connect to localhost and using that local port, but it will go through over SSH tunnel to the remote machine. This could be sometimes very handy, especially if you deploy to production, for example. If you need to do some production cache flushing, and the only way to access production is through dump server, this could be a way to implement that. And of course, you can use all the libraries, all the classes that are available in Groovy, and then to help you out with that. So we can open different interfaces in this way. Also, Sshoogr provides prefix and suffix commands, which allows you to basically add sudo, for example, to all the commands that are executed inside the block, and the same with the suffix. Quite obvious. Okay, summarizing stuff. So what I want you guys to kind of take away from this presentation is that if you are, and probably you are, deploying, developing, maintaining Java applications, Java projects, Groovy is a natural choice for implementing automation and scripting on top of those, because Groovy scripts are portable, Groovy scripts are concise, Groovy scripts are powerful, and you basically can reuse all the knowledge you have from JVM already, and also take the knowledge that I exposed in previous slides. Thank you very much. Any questions? No?
Have you tried Ansible and other scripts?
Yeah, absolutely.
Yeah. How does this compare?
Well, they're all good tools, definitely. I also use Ansible, I also use Puppet, but Ansible and Puppet, they're more like provisioning tools, which probably should be used for more complex setups. Because both Ansible and Puppet, they define the state of your infrastructure that you want to provide. They declare, they're declarative languages. In case of Sshoogr, in case of Groovy in general, it's basically ad hoc automation or automation for not necessarily for infrastructure management, but for tasks like cache flushing, for tasks like restarting servers, because Puppet and Ansible, they naturally don't support this kind of flows, and you still need scripting for this kind of tasks, and then Groovy is a good choice there.
So you wouldn't use Groovy for provisioning?
For simple stuff, yes. For complex stuff, no, because Ansible and Puppet and Chef, they do it better and much more declarative in that sense. So if you have to configure full setup, I don't know, with logic, database, for example, and all the permissions, all that stuff, I would use provisioning tool for that, because they're meant for that. But for ad hoc scripting, for tasks that need to be executed on demand, I would use scripting languages like Groovy, for example. Okay.
Okay. Thank you very much.
Thank you.